This video, we're going to prove the following number theory fact. It's very interesting. Let n be any integers. If m is obtained just by switching the order of the digits of the original number n, then 9 will divide the difference. So what exactly does it mean by m is obtained by switching the order of the digits? Well, if n is 7 to 5 and you switch the order, 7 to 5, this difference, which looks to me to be 198, is going to be divisible by 9. 9 goes into 198. Goes in 2 times with 1 left over, and 9 goes into 18 evenly 2 times. That is no remainder. That is 9 did divide this. Okay. Now, before we get into the proof, there's a couple of things we need to get out of the way. 10 is congruent to 1 modulo 9. So if I multiply these two numbers, say by 10, I get 10 squared is congruent to 10 mod 9. But we just got through saying that 10 is congruent to 1 mod 9. And again, if I multiply those two digits by 10, I get 10 cubed is congruent to 10 mod 9. There it is again. That's congruent to 1 mod 9. In fact, and I'm not proving this fact, you can do it easily by induction, but if we continue, 10 to the k is going to be congruent to 1 mod 9, where k is any positive integer. Can it be? Yeah. It can be 0. 10 to the 0 is 1. Any positive integer. Okay, so let's record that result up here. 10 to the k is congruent to 1 mod 9. Now, c times, so we know that 10 to the k is congruent to 1 mod 9. If I multiply both sides by c, which is allowed, well, of course it's allowed, but the mod doesn't change. It could be that maybe that those two would be congruent in mod 9 times c, or 9 to the c, but the mod doesn't change. That means c times 10 to the k is congruent to, well, c times 1 is c mod 9. Let's record that one. C times 10 to the k is congruent to c mod 9. Okay, so now we're in a position to start the proof. And as always, at this point, I like to state that if you like seeing mathematical proofs, you should seriously consider subscribing to this channel, as that's all we do here. Mathematical proofs. A few per day. Click the like button. Leave a comment. Once again, subscribe. So let us define n. Let n equal to a number in base 10, the base that we normally write numbers in, and let's write it in what's called standard form. So n is a sub n, 10 to the m plus a sub m minus 1, 10 to the m minus 1, all the way down to a1 times 10 plus a0. So m is just reversing the digits. That is, a sub 0 is going to come first, plus, or a1 will be next, all the way down to a sub m minus 1 times 10 plus a sub n. Now, I want to just comment on something. If you want to write up a really rigorous proof, you probably should do this in 2 cases, but I'm not going to. If you have an odd number of digits and you write it in reverse, A, B, C, D, E, you're going to have a middle. And it turns out that that middle is going to come out to 0. It'll be 0 times 10 to some power. Okay, that is, it's not going to really remain. If you have an even number of digits, A, B, C, D, E, F, and you write it in reverse order, there's no need for in any column for there to be the same digit. So here we don't have a middle digit. Okay, we don't have a middle digit. So I'm kind of doing the proof where we don't have a middle digit, which happens when m is odd. So again, maybe you should do this in 2 proofs. In 2 cases, and I'm just doing the case where m is odd. Don't want anyone to say in the comments that it may not, my proof isn't 100% valid. I'm doing a disclaimer and stating that I'm only really doing the proof where m is odd. So what is m minus n? Well, if you subtract these, you get am minus a0 times 10 to the m. I factored out 10 to the m, and here I'm going to factor out 10 to the m minus 1. So I get am minus 1 minus a1, 10 to the m minus 1, all the way down to a1 minus a sub m minus 1 times 10 plus a0 minus am. And I want to do all of this in mod 9. Okay. Now, when it comes to adding mod 9, if you have a plus b plus c and even more mod n in general, this is a mod n plus b mod n plus c mod n, not capital N. So, and so on. It doesn't just have to be 3 terms. We have n plus 1 terms here. This mod 9 is just going to equal to am minus a0. I said that up here. A constant times 10 to a power is just c. Well, here's a constant, and here's times 10 to a power. So I just got back the constant. Plus this mod 9. Well, that's just the constant. All the way down to this mod 9. That's including the times 10. That's a1 minus am minus 1. Plus this mod 9, which is a0 minus am. And this whole thing mod 9. Now, independent of what the mod is, I claim what's in the bracket is 0, mod 9. And it's 0 because, remember, if you have r and you add negative r, you get 0. So if you have a minus b, maybe we'll stay away from a's and b's. If you have m minus n and you take away and you add the reverse, you're gonna get 0. This and the last one, they add up to 0. This one and the second one from the left and the second one from the right, they add up to 0. And the third from the left and the third from the right, they add up to 0. And so on. If you don't have a middle one, then the ones on the left and the ones on the right, they all cancel out to 0. If you do have a middle one, it's gonna be 0 anyways. So maybe there is, well, you should write out the full proof. I have the luxury of just stating it. Okay, so what we have is, let's write it here. We have that n minus m is equal to 0. That means 9 must divide this minus that. But, of course, this minus that is just n minus m. So 9 does divide the difference of two numbers where their digits are in reverse order. Okay, there it is. Proven. Now you don't have to accept it anymore. Stop accepting math. Math is not something that you can just accept. Now, being a student at the City University of New York system, they made that extremely clear to me. Don't accept anything. Prove it. Make sure you have it down. See you guys in the next video. Watch and learn.